5 says show that vector of m comma n is equal to a raised to the power of n 1 plus a all raised to the power of m integral from 0 to 1 of s raised to the power of m minus 1, then 1 minus s raised to the power of n minus 1 all over x plus a raised to the power of m plus n ds. So this is what we are going to prove. Now recall from the polynomial definition of the beta function. The polynomial definition of the beta function says that beta of m comma n is equal to an integral from 0 to 1 of s raised to the power of m minus 1, 1 minus s raised to the power of n minus 1 ds, and that is what that's where I'm going to start from. This is the substitution I'm going to make. Let s over 1 plus a be equal to t over t plus a. That is what I'm going to be using. So I will differentiate. This one will give me 1 plus a ds. Differentiate with respect to x. All this 1 over 1 plus a is a constant. So that's why I have 1 over 1 plus a ds equal. Then differentiate this with respect to t. This one using quotient rule. This one will be t plus a multiplied by 1 minus t multiplied by 1 all over t plus a all squared dt. So that at the end of the day, 1 over 1 plus a dx is equal to, this one is t plus a minus t. I will just be left with a all over t plus a all squared dt. So the s, it means that the s is equal to a 1 plus a over t plus a all squared dt. So the next thing I will be doing here is I need to make, when s is 0, of course when s is 0 t is 0, and when s is 1, I have 1 over 1 plus a to be equal to t over t plus a. This one will give me t plus a to be equal to t plus at. So t cancel t, then that means t will be 1. T cancel t, a will cancel a, and a will be 1. So that means when s is 0, it follows that t will be 0, and when s is 1, t will also be 1. So now I will substitute into the integral beta of m comma n to be equal to integral from 0 to 1 of s. S is all these multiplied by t plus 1 or 1 plus a. If you make s the subject of formula here, just transfer this 1 plus a to the other side. S will be equal to t 1 plus a all over t plus a. That's what you are going to have. So it means that s is t 1 plus a all over t plus a, everything raised to the power of m minus 1. Right. So the next thing, multiply 1 minus s, that is 1 minus t plus ta or at, then I have 2 plus a. That is from here. Open the bracket at the numerator, you have this. Then I have raised to the power of n minus 1 multiplied by dt. dt, ds. ds is a 1 plus a. The s will be a 1 plus a all over t plus a all square dt. So this will be integral from 0 to 1. Open the bracket here. This one will be t raised to the power of m minus 1. 1 plus a raised to the power of m minus 1 over t plus a raised to the power of m minus 1, then multiply by the time you do this one will become, by the time you do this one will become t plus a, this one will become t plus a minus t a all over t plus a, everything raised to the power of n minus 1. Then this a raised to the power of 1 plus a raised to the power of 1 plus a over t plus a all square dt. So this will be equal to integral from 0 to 1 of t raised to the power of m minus 1 plus a raised to the power of m minus 1. Then t will cancel t, that will be out. T cancel t, I will be left with a minus ta, factorize a, so that this one will just become a raised to the power of 1 minus t, everything over t plus a. Oh, I forgot this, t plus a raised to the power of m minus 1. Then this is n minus 1 multiplied by a, 1 plus a all over t plus a all square dt. So the next thing will be equal to integral from 0 to 1 of, bring all the t's together, I just have t raised to the power of n minus 1, multiply, then bring all the a's together, this is a raised to the power of n minus 1, a raised to the power of n minus 1 multiplied by another a, that is plus 1, then this 1 plus a is raised to the power of n minus 1, then I have another 1 plus a here, that is plus 1, then I have 1 minus t raised to the power of n minus 1, 1 minus t raised to the power of n minus 1 all over, then I have t plus a raised to the power of t plus a raised to the power of n minus 1, this is also t plus a raised to the power of n minus 1, so that is plus n minus 1, this is square plus 2 dt. So that at the end of the day, this is a raised to the power of n, 1 plus a raised to the power of m, they are constant, bring them out. So I have a raised to the power of n, 1 plus a raised to the power of m, that's all. Then I have integral from 0 to 1, this is t raised to the power of m minus 1, 1 minus t raised to the power of n minus 1 all over, this is t plus a raised to the power of n plus n. Minus 1 plus 2 will give me 0. So the t. So that's what I have. So that at the end of the day, I can just change the s to t, the t to x. So beta of m comma n will be equal to a raised to the power of n, 1 plus a raised to the power of m, integral from 0 to 1 of s raised to the power of n minus 1, 1 minus s raised to the power of n minus 1, all over t plus a raised to the x plus a raised to the power of n plus n dx. And that's all. That's all about that. From 6 is the next one we want to do. So from 6, is saying that show that 6a show that beta of m comma n is equal to 1 over a minus b raised to the power of n plus n minus 1 integral of from b to a of s minus b raised to the power of m minus 1 a minus s of n minus 1 ds. That is what I have first. So then the b part is show that as well. Show that beta of m comma n is also equal to 1 over 2a everything raised to the power of n plus n minus 1 n plus n minus 1 of integral from minus a to a of a plus s raised to the power of m minus 1 a minus s raised to the power of n minus 1 ds. So again, s or otherwise, evaluate the first one, a integral from minus 1 to 1 of x plus 1 raised to the power of m minus 1, then 1 minus s raised to the power of n minus 1 ds is equal to 2 raised to the power of n plus n minus 1 beta of n comma n. And the second one, we want to evaluate integral from 5 to 7 of x minus 5 raised to the power 6, then 7 minus x raised to the power 3 ds. We want to compute this. So now let's see how we are going to compute this. We are going to find a, then from a we will show b. After showing b, we will also use it to show this c and d. Let's call this c and d. So that's what we are going to be doing in this place. So I'm going to use the polynomial definition. Beta of m comma n is equal to integral from 0 to 1 of s raised to the power of n minus 1, 1 minus s raised to the power of n minus 1 ds. I'll let s to be t minus d all over a minus b. T minus bs all over a minus b. So differentiate, the s will be equal to 1 over a minus b dt. We can try to make s t the subject of formula. If we make t the subject of formula here, t will be equal to b plus s a minus b. B plus s a minus b. That is what t will be in this case. So now when s is 0, when s is 0, it means that t will be b. And when s is 1, that will be b plus a minus b. T will be a. So that means this vector function b of m comma n will actually be equal to integral from b to a of s. S is all this. That is t minus b over a minus b raised to the power of n minus 1 multiplied by 1 minus x. That is t minus b all over a minus b raised to the power of n minus 1 ds. ds is 1 over a minus b. 1 over a minus b dt. So without wasting time, this one will be equal to integral from b to a of this will be t minus b raised to the power of n minus 1 over a minus b raised to the power of n minus 1 multiplied by this will be a minus b minus t plus b. That will exactly give me a minus t raised to the power of n minus 1 over a minus b raised to the power of n minus 1 multiplied by 1 over a minus b dt. So the next thing to do is what we are going to be doing next, vector of m comma n will be integral from b to a of this will be t minus b raised to the power of m minus 1 a minus t raised to the power of n minus 1 all over this one will be a minus b. This is m plus n, m minus 1 m minus 1 plus n minus 1 then raised plus 1 with t, so that everything will become integral from b to a. Everything will become integral from b to a of t minus b raised to the power of n minus 1 a minus t raised to the power of n minus 1 all over this will be a minus b. This is m plus n minus 1, which is a constant, so we can bring it out of the integral. So I have 1 over a minus b raised to the power of n plus n minus 1 integral from b to a of t minus b raised to the power of n minus 1 a minus t raised to the power of n minus 1 dt. And we are done. We can just change the t to x and that will be all. So that's for b. For a, therefore vector function of m comma n will be equal to 1 over a minus b raised to the power of n plus n minus 1 integral from b to a of x minus b raised to the power of n minus 1 a minus x raised to the power of n minus 1 ds. And that's all. That is the answer, or we have proved the first one. Now to come to b, to prove b is very simple to prove. We are going to use a to prove b. So for b, to prove b, just let b to be equal to minus a. In the first one, in a, don't forget a says that b of m comma n. Don't forget b says that B says that B of n comma n is equal to 1 over a minus b raised to the power of n plus n minus 1 integral from b to a of x minus b raised to the power of n minus 1 a minus s raised to the power of n minus 1. Yes, so replace anywhere you see b, put minus a, put negative a. So this one will now become 1 over a minus a. That's a plus a, which will be 2a. That will be 2a raised to the power of n plus n minus 1 integral from minus a to a of, this one will become plus s plus a of a plus s. S plus a or a plus s. Then this will become a minus x raised to the power of n minus 1 ds. And that is what we are told to do in B. Now we want to evaluate this for C. So in this case, we want to show this. We want to find integral from minus 1 to 1 of x plus 1 raised to the power of n minus 1 minus x raised to the power of n plus 1 ds. We want to show that it's equal to 2 raised to the power of n plus n minus 1 vector of m comma n. So what we just need to do in this B, just let a be equal to minus 1. Oh, let a be equal to 1. Let a be equal to 1 in B. In this B we have just proved. It means that the beta function of mn is equal to 1 over 2 times 1 will give me 2 of n plus n minus 1 integral from minus 1 to 1 of x plus 1 raised to the power of n minus 1 minus x raised to the power of n minus 1 ds. So at the end of the day, just bring this to the other side and you have your answer. This one will be integral from minus 1 to 1 of x plus 1 raised to the power of n minus 1 minus x raised to the power of n minus 1 dx will be 2 raised to the power of n plus n minus 1. Then the beta function of m comma n. That is all for C. Now for D, let's try to compute for D. The last one, and this from 6. For that question, I have integral from 5 to 7 of x minus 5 raised to the power 6 and then 7 minus s raised to the power of 3 ds. If you look at from 1 very well, from 1 or from A rather, from A, this one, the meaning is that let A be equal to 7 and let B be equal to 5. Then you let M, look at what I'm trying to do, 7, 5. I said let A be equal to 7, B be equal to 5. So I have M minus 1. This is for x minus 5. That's B. B is 5. Raised to power 6. So that means M minus 1 will be 6. That means M will be 7. So you let M to be 7. And then you let N to be 4. So from 1, it means that beta of M now is 7, N is 4. That is 7, 4 will be equal to 1 over A minus B. A is 7 minus B. B is 5. Raised to the power of n plus n. That is 7 plus 4. That is 11 minus 1, 10. That is raised to power 10 integral from 5 to 7 of x minus b, that is 5, raised to the power of 7 minus 1, then 7 minus s raised to the power of 4 minus 1 ds. At the end of the day, you will see that integral from 5 to 7 of x minus 5 raised to power 6, which is all this I have here, and 7 minus x raised to power 3 ds will be equal to 7 minus 5 is 2 raised to power 10 beta of 7 comma 4. So this is 2 raised to power 10 multiplied by, how do we evaluate beta of 7 comma 4? We use gamma of 7, gamma of 4 over gamma of 11, and this will be equal to 2 raised to the power of 10 multiplied by gamma of 7 is 6 factorial multiplied by gamma of 4 is 3 factorial all over gamma of 11. Gamma of 11 is 10 factorial. So you evaluate all these, and I think the answer will be 512 over 105. 512 over 105. And that is the answer. Let's go to the last form from 7. From 7 of the transformation of the gamma function, of the beta function, show that, so this is also split into 2 parts, show that integral from 0 to 1 of s raised to the power of n minus 1 1 minus s raised to the power of n minus 1 over a plus b minus a s raised to the power of n plus n is equal to 1 over a raised to the power n b raised to the power of m beta of m comma n. Then the b part is saying that we should also show that integral from 0 to 1 of s raised to power n minus 1 1 minus s raised to power n minus 1 all over b plus cs raised to the power of n plus n, b plus cs raised to the power of n plus n ds will also be equal to 1 over b plus c, 1 over b plus c raised to the power m, b raised to the power n beta of m comma n, where m comma n will be greater than 0. So, how are we going to solve this? This is the substitution we are going to make. The whole essence of all this form, or the whole approach to solving them, is for you to just know the right substitution to make. Once you can get the right substitution to make, you are going to, it will be trivial from there. So here you let a over t minus b over x to be equal to a minus b. That's what I just need to do. That's the substitution I'm going to be using here. So from there, I will make to the subject of formula. To make to the subject here, I just have a over t will be equal to A over T will be equal to A minus B plus B over X. Then T over A will be equal to S over A minus BS plus B. So I reciprocate. I reciprocate both sides so that T will now be equal to AS over A minus BS plus B. That is the first substitution to make, so that you will get the bound when S is 0. When S is 0, T will be 0, obviously. And when S is 1, T will be 1. This one will be A minus B plus B, which will give me A. A over A will give 1. So now it is left, or I am left with differentiating. But I would like to make S the subject of formula when I'm differentiating, so that I will have X. To make S the subject, I have B over X, which is equal to, I have B over S, which is equal to A over T minus A minus B. That's what I'm going to have. So that X over B, reciprocate again, will be T over A minus B T. Another way to write this is to write T over A plus B minus AT. So take B to the other side, S will now be equal to BT over A plus B minus AT. So where am I substituting this into? The integral I'll be working on here will be the definition of the gamma function, of the beta function. And the definition of the beta function, that is the polynomial definition. Beta function of m, n is equal to the integral from 0 to 1. Integral from 0 to 1 of s raised to the power of n minus 1, then m minus s raised to the power of n minus 1 ds. That is what I'm going to be using. So now this is equal to, of course I have checked for when s is 0 and when s is 1 is still the same bound. So that is integral from 0 to 1 of x, or I have not differentiated the s, the t. So here the s will be equal to, using quotient rule, this one will be a plus b minus a t multiplied by b minus bt multiplied by b minus a multiplied by b minus a. That's what I will have all over a plus b minus at all squared dt. By the time you evaluate this, this is what you are going to have. B minus abt, we cancel this one, you will be left with ab. You are going to be left with ab actually. So this one will now be ab dt all over a plus b minus at all squared. So s, this is bt all over a plus b minus at raised to the power of n minus 1. Then I have 1 minus s, that is 1 minus bt all over a plus b minus a t, everything raised to the power of n minus 1, then multiply by ds. ds is also ab, the t, all over a plus bt, a plus b minus a t all squared. So this will actually give me integral from 0 to 1 of, this will give me b raised to the power of m minus 1, c raised to the power of m minus 1 all over, everything at the denominator here will be a plus b minus a t raised to the power of n minus 1 multiplied by, I will find the LCM here, this one will become a plus bt, this one will be a plus bt minus ap minus bt, everything over a plus b minus at raised to the power of n minus 1, then multiply by ab over a plus b minus at all squared. That is what I have. So to round off, this without wasting time, it means that beta of m comma n will be equal to integral from 0 to 1 of, this one will be bm minus 1 tm minus 1, bt we cancel out, bt minus bt we cancel out, bt minus bt will cancel out, so I'll be left with a minus at. I can factorize a to have a open bracket 1 minus t, so that I will have as numerator a raised to the power of n minus 1, then 1 minus t raised to the power of n minus 1. That is what, then multiply by ab, the t, multiply by ab, that is what I will have as the numerator. At the denominator I have a plus b minus a raised to the power of t raised to the power of n minus 1 first, again raised to the power of n minus 1, that is plus n minus 1, then raised to the power of 2 plus 2. So beta function of m comma n will just be equal to integral from 0 to 1 of bm minus 1 multiplied by b will give me bm. This is bm. An minus 1 multiplied by a will give me an. Then I have tn minus 1, 1 minus t raised to the power of n minus 1 all over. Then at the denominator I have a plus b minus a t raised to the power of n plus n raised to the power of n plus n. An and bm are constant, they can come outside the integral. When they come out, I divide both sides by an and bm, so that at the end of the day I'm going to have this integral from 0 to 1 of bm multiplied by a. I don't have bm inside again, I have t m minus 1 multiplied by 1 minus t raised to the power of n minus 1 all over a plus b minus a t raised to the power of n plus n dt will be equal to beta all over all these ones I brought out to divide all over an dn. So to do b, to get b, The first thing you are going to do here is that you will replace A with B. You will replace A with B and B with A. That is the first thing to do. Replace A with B and B with A in one. In A rather. So if I do that, this one, it means that I will have integral from 0 to 1 of t raised to the power of n minus 1, 1 minus t raised to the power of n minus 1, all over. This one will now become b, plus this one will become a minus b. A minus b t raised to the power of n plus n dt, and this one will be equal to beta of mn over a is now b, that is b raised to the power of n, then a raised to the power of n. So after we've gotten this, then you let c be equal to a minus b. So you make a the subject from here. Let c be equal to a minus b, so that then make a the subject of formula. A will be equal to c plus b, or b plus c. So we'll put it inside it as well. So if I let that, what will happen is that I will have an integral from 0 to 1 of t raised to the power of n minus 1, 1 minus t raised to the power of n minus 1 over, I have b plus a minus b is now c, so I have b plus ct. So b plus ct, this one will now become raised to the power of m plus n. The t is equal to b of m comma n over a is b plus c. So a is b plus c. So if I replace a is b plus c, so I have b plus c raised to the power of n, because that is a, b plus c raised to the power of n, then b raised to the power n. And that is the answer.